How does man think? Can man ever fly?
What is there?
Can we go there?
Speculation about ourselves, our universe, and our future has fascinated the most complex minds and the most naive. We have trusted the future to evolve answers to our questions, and technology to create the tools to accomplish them. But today, we're unraveling man's genetic mysteries. We fly. We've been out there and come home again. At the speed we're traveling, the future is now. And education and technology must combine to teach us to live and work today. They meet at Seneca College, where students blend science and the arts to prepare for the challenges of today's world. For Seneca to be this meeting place is appropriate. Its 13 campuses thrive in Metro Toronto and York region. The name Toronto echoes the Indian word for place of meeting, and Seneca Indians were leading members of the renowned Six Nations of Iroquois. Proud and politically astute, the Senecas were respected for bravery and power, and for their ability to recognize changes in their world and create alliances to exploit them. So it is today. Seneca is constantly changing, responding to new demands, creating innovative programs, moving forward. For us, the future is now. As the impact of microelectronics increases in homes, business, and industry, the profusion and diversity of high-tech applications at Seneca is significant evidence of the college's commitment to leadership in education.
The foundation of advanced technological studies is a thorough grounding in traditional techniques. At Seneca, students begin in a traditional machine shop, then progress to an advanced manufacturing laboratory.
Intricate mini lathes, home techniques of computer-assisted manufacturing. On full-size equipment, these skills produce parts to exacting tolerances. Vertical cutting also responds to the minute adjustments of computerized control. To verify accuracy, students use a coordinate measurement computer, which detects variations of 1/1000th of a millimeter, 1/10,000th of an inch.
Move forward, pick up, turn. It's voice activated or keypad controlled. This robot arm and its big brothers can improve productivity in Canadian industry.
Its biggest brother, the Canadarm from Spar Aerospace, is one of the triumphs of the Space Shuttle program. 18 Seneca graduates worked on this masterpiece of Canadian manufacturing.
This is computer-assisted design. It's a practical resource for many program areas of the college.
24 hours a day, students acquire or upgrade drafting skills and develop their computer programming talents. Machining instructions are stored on punch tape for input to a numerical control machine. High-speed plotters print hard copies of each design stage. To assist medical research, 1 scanning and 2 transmission electron microscopes train students in the intricacies of tissue analysis. Biochemistry and biotechnology combine science with training in methods to prepare students for roles in biological research and pharmaceutical manufacture, among others. Lathes, robots, computers, microscopes. At Seneca, technology wears many faces. but it never masks the college's goal of a well-rounded education for its graduates.
You can't get technical competence in isolation. You need fundamental literacy skills, mathematics, communications, creative problem solving, logical and critical thinking, people skills. You get these in English and liberal arts. They're critical components of all technology programs at Seneca.
At Seneca, advanced technology enlivens the instructional process. Computer terminals are everywhere.
The Health Science Test Item Data Bank of multiple choice questions allows students to monitor their knowledge of many complex aspects of the nursing and dental programs. These interactive computer tests supplement conventional classroom instruction.
Other courses, like marketing, business, and fashion design, have similar data banks from which teachers can construct tests and simulate real-life situations. In the Athletic Center, a computer compares personal fitness levels to accepted norms. Design arts and illustration students create media graphics through links to mainframes. Even children aged 8 to 14 build computer familiarity through special programs. Secretarial science students, studying to work in the paperless office, achieve general or specialist level skills using Seneca's sophisticated word processors. Computer-assisted instruction allows students to learn directly from a central computer at their own pace. On the hardware side, students use microprocessor and data communications laboratories to learn to combine and apply electronic elements to create data links, to manufacture the myriad of machines required by our automated world. And of course, specialized studies in computer programming, systems analysis, and operations serve the exploding need for information processing in our electronic society. Hundreds of microterminals are in constant use by full-time, part-time, and adult retraining students. Computers, integral to today's way of living, central to Seneca's high technology commitment.
Seneca's programs are not limited to strictly on-campus types of activities. Through the Business and Industrial Training Division, provincial funds are channeled directly to companies to assist them in retraining and upgrading the skills of present employees. These programs are concentrated in advanced technology areas.
In courses like civil, resources, and computer engineering, programming, and system analysis, and in the chemical and pharmaceutical fields, cooperative education programs allow students to combine ongoing studies with practical work experience. It's an excellent foundation for their future.
At Seneca, technology isn't limited to computers. Applications are widespread and diverse.
Our students in underwater skills get right up to offshore regulation standards. An important part of their training is spent right here in this recompression chamber.
Ready to take two. Take two. Stand by to roll tape.
Other students acquire skills in radio and television technique, applicable to either broadcast or industrial requirements.
In cooperation with the teacher-producer, the Media Center films and edits educational support material for college-wide use. Much of this material is a vital component of diploma programs offered at the Center for Independent Learning. These programs are designed for individualized, self-paced instruction. Seneca programs are also broadcast on Global and City TV in Ontario and are offered to Armed Forces personnel in Canada and Europe.
No, it's not a dynamite trigger, but it's powerful. This nuclear densometer measures soil density and water content by emitting radioactive rays into the ground. It ensures that embankments and foundations will withstand the pressures they will face. Ultra-modern electronic tachyometers replace the surveyor's theodolite and use infrared beams to record distance and elevation data. Stored in handheld or internal memory, these instruments offload information into the mainframe computers, from which hard copies and plots can be extracted quickly.
Two tachyometers in tandem can measure in 3 dimensions. That allows us to do things like check the symmetry of a parabolic dish antenna to make sure that the satellite signal reception will be exactly right.
Also in the surveying field, a computer linked to sensors and viewers allows exact 3-dimensional analysis of aerial photos. A photo reconnaissance mission? Maybe someday. But today, it's a Seneca flight student doing touch and goes, practicing takeoffs and landings.
So that we get the most out of our actual flight time, we all spend hours in these 2 flight simulators. Instructors feed in situations and problems and assess the reactions. It's really a great course if you want to get flying.
At Seneca College, we are committed to leadership in education. We're responding to today's demands from business and industry, and we're preparing to meet tomorrow's demands as well. We're stepping forward and challenging the future, because at Seneca, the future is now.